Hello everyone. Today we're going to learn about implicit differentiation. So implicit we have to use the formula for implicit differentiation only when there is two functions in the same equation, like this and like this. How can we solve it? We cannot use the normal method as before, but we have to manipulate the equation. So now let's look at this example. X square y plus xy square equal to 6. Okay, so for implicit differentiation, this first step is to differentiate both sides of the equation with respect to y, while treating y as differentiable function of x. Okay, we'll see about that later. And the second step is to collect the terms. This is what you mean by collect the term with dy dx on one side of the equation and solve for dy dx. So for your syllabus, you have to solve for dy dx up until this point. Okay, until you can get this. So this is the final answer. Okay, so let's look here. Okay, sorry. So the ddx of x square y, x square y plus xy square dy dx of 6. Okay, so when you derive 6 with respect to x, you will get 0. So now we have to only concentrate on this part here. Okay guys, so first what you should do, remember, first this is my formula anyway, but it also aligns through with the theory. Okay, this formula makes me easier to remember the theory. First, you from the left, okay, copy x and differentiate y. So how? Copy x, differentiate y. So since we are differentiate it against dy dx, so we have to write it like this. Okay, and then looking at the same equation again, this one x square y, second step is to copy y. Okay, copy y and then differentiate x. Okay, So for x square y here, copy y plus y and then differentiate x, you will get 2x. Okay? Can you understand this part here? So for x square y here, for implicit, we have to use the implicit differentiation because there is two functions in this x square y in this equation. So first, how to do the implicit differentiation? First step is to copy whatever x function here. Okay, we have copied here, and then differentiate y. Differentiate y, you will get dy dx. Why is it differentiate y, you will get dy dx? Okay, why? Why? Okay, this is why. I show you. Okay, differentiate. Okay, for this part here, differentiate y, you okay. So for here it will be the d dx of y. Okay, we have to go back to our original theory. Okay, so to differentiate, this is y to the power of 1. When you differentiate it, the 1 will become 0 and this one will become y to the power of 0, and this will be dy dx. So y to the power, we will get 1, so it will be, okay, this is y. This is y. This become dy dx. When you differentiate y, you will get dy dx. Okay? And then next part is copy y. Copy y for the x. We are still looking at x square y here. Okay, copy y and then differentiate x. Differentiate x square, you will get 2x. Okay, is that clear? Okay. Okay, and then moving on to this equation, xy square. Okay, now copy x. Okay, x. And then differentiate y. Differentiate y square here. Okay, how? Okay, let's. Okay, let me, where do we going to do this? Okay, can we do it here? I hope you can understand it. Okay, so the dx of y square. Okay. Okay, so you will get 2y dy dx. Okay, 2 brought to the front, and then y should be to the power of 1, and that will be 2y dy dx. So copy x and differentiate y square, which is y square here, you will get times 2y dy dx, and then plus with, okay, so okay, and then next step is copy y, which is y square here, and then differentiate x. Differentiate x, you will get 1, and everything is equal to 0. So the next step is to collect the terms with dy dx. So collect the terms with dy dx. Okay, let me erase something here first. Okay. Okay, collect the term with dy dx. So dy dx, okay, what we have is x square, and then n plus 2xy, right? Okay, and the one with no dy dx is 2xy plus y square equal to 0. Okay, now to make it easier, we have to move this part here to the left hand side. Negative 2xy minus y square, and dy dx is minus 2xy minus y square over x square plus 2xy. Okay, easy peasy, right guys? Once you understand this part here, okay, and then do the collection of the terms with dy dx, and then it is over. Okay, so now let's look at a few example here. Okay, so now we have a here is x cube plus y cube equal to 18xy. So the d dx for this should be written like this: x cube plus y cube equal to the d dx of 18xy. Okay, remember first for x cube is pretty straightforward. The d dx of x cube should be 3x square plus, but what about this here? Okay, for this you have to differentiate y. Okay, differentiate y, you will get 3y square dy dx. Okay, and then since this is the multiplication of two functions, we have to do the copy x differentiate y first, and then copy y differentiate x. Okay, so now let's do this. 18 letak kat luar dulu. Okay, and then just the d dx of xy. Okay, so the d dx of xy, first I will write again here, copy x differentiate y. So copy x differentiate y, you will get what class? Dy dx, and then plus copy y. Next step is copy y differentiate x. Okay, copy y differentiate x, you will get 1. Okay, so now this part here can be rewritten like this: 3x square plus 3y square dy dx equal to 18 x dy dx plus y. Okay, and then we pull every dy dx together. You should get dy dx 3y square minus 18x, and this part here should be 18y minus 3x square. Okay, so dy dx should be what? Okay, really easy. 18y minus 3x square over 3y square minus 18x. Okay, x. Okay, so this is the final answer. Okay, now let's look at example B. Okay, B is three x okay, this is okay, wait, the original question is like this. There must be some typo mistake. 3x square plus 7 to the power of 2 equal to 6y. Okay, so here it is, 3x square plus 7 to the power of 2, 6y, and then the ddx for this is 3x square plus 7 to the power of 2, 6y. So following chain rule, we should solve the outer layer first. So the outer layer is, okay, put 2 at the front, 2 and 3x square plus 7 to the power of 1, and then times with the ddx of whatever in the bracket, which is 3x square plus 7. And then for this part here, differentiate 6y, you will get 6 dy dx. Okay, so now 2 times 3x square plus 7 times with the ddx of this part here is 6x, and this one should be 6 dy dx. Okay, 6 here can be cancel, so dy dx is just this. Okay, so this is the final answer. Okay, now let's move on to the next question. Okay, xy equal to cot x. Okay, xy equal to cot xy. So remember, copy x, differentiate y. For this part here, copy x, differentiate y, you will get, okay, copy x, differentiate y, you will get dy dx. Okay, plus with copy y, differentiate x. Copy y, differentiate x against x, you will get 1. And then for this part here, differentiate cot xy, differentiate cot, you will get minus cosecant square xy, and then times with the ddx of whatever in the bracket. Okay, which is the ddx of xy. Okay, so the ddx is y. Isn't it the same as this part here? Right. Okay, so you just have to rewrite it here. Okay, negative cosecant xy, and then the ddx is the same as this part here, so it should be x dy dx times plus y. Okay, Okay, and then pull every dx dy together. You will get x and then x plus x cosecant square xy and this part should be cosec y minus okay, minus cosecant square xy minus y. Okay, so dy dx is minus y cosecant square xy minus y over x plus x cosecant square xy. Okay, so this is the final answer. Okay, now let's move on to example D. Okay, so for example D, x to the power of 4 plus sine y x cube and y square. So the d dx for this, should be, okay, d dx of x to the power of 4, you will get 4x to the power of 3, and then for the d dx of sine y, you should get cos y. Don't forget to write dy dx. Okay, and then so this copy x, differentiate y. You have to do that. Okay, so copy x, differentiate y, you will get 2y dy dx plus copy y, differentiate x, you will get 3x square. Okay, so now pull together the dy dx terms. You will get cos y minus two x cube y. Okay, and this part here should be okay, 3x square y square minus 4x cube. So dy dx is okay. So this is the final answer. Okay, if you have any question about this subject, please do not hesitate to contact me. Okay, bye guys, till next time.